Hi sir, I'm Heng Xiang, and now I will present about the SML, logical view, and DDT. For the part A, our group have choose the food ordering system. Then the question 1 require us to write a SML document with at least X child element, 1 empty element, and 2 attributes. Requirement, we have include X category with their ID such as C01, 2, 3, 4, 5, 6, 7, and 8. Then each category have include one empty element, which is the category image. There are also more than 2 attributes in each category. For example, the category ID, item ID, and the image file. Section 2 requires us to draw the logical view with first and second child element. Our logical view, both of the child element is similar, and the only difference between the element is their ID and their name. In the question 3, we have write the external DDT on the SML include element, attributes, and entity. For the attribute, we have also consist the ID and the ID reference, which is the item ID and category and ID reference. Lastly, we have declared the entity by internally. That's all for my presentation. Thank you.
Hello everyone, my name is Abdul. In my part of the video, I'm going to talk about question 4 and question 5 for part A for TCP3151 project. So without further ado, let's begin. So this is the XLT for the food ordering system. So now we proceed with the first step, the first apply templates here. So this apply template is going to use the food ordering menu. So later we will talk about this in bottom later. So it will apply a sorting. So sorting is based on the category name. So which means that category name will be displayed in ascending order. So we proceed with the menu first. So the menu, when template match menu, it will select category. Okay. So when it select category here, the category template here will be used. And then as we can see here, it will first display the category name in the category, and then the items will be displayed in the items container. So the items name will also be sorted in ascending order. Then when it select the items, like the template match items here, so firstly the item image will be displayed. Okay, then the items name will also be displayed, where you select name, then price, choice. There's a special thing in choice here because we use code template. So in this code template, we are going to use the render choices template with parameter name choices, select choices, choice. So the render choice is here, then the parameter name is choices, and then in these choices, we are going to apply a template for choices. Okay, so the choices here, the choices will be displayed in input type radio, which are the radio buttons. So the radio buttons, the structure of radio button here. So input type radio in this template called choices/choice. Okay, and then the name is the Manchester of the item ID. The value of select, which is select choice. So choice will display normally with the radio buttons. After that, so we proceed with the customization option, which is here. Okay, forgot to talk about the XSL if. So if the choice are available, which means that the choice can be searched from the XML file, so it will be displayed. So this if is to check whether choices are existed in the XML file. Okay, so same goes to the customization. So this XSL if is also applied here for customization. So if customization is available, so this will be displayed. Okay, so apply template select customization. So we proceed with the customization, which is this one. So the customization will be displayed with checkbox, which allow the user to tick the box when they want to apply these customization. Then we have add to order button here to let the user to click, but there's no any function since this is a static web page. Okay, so next we proceed with the order section. The order section here, we just do it statically, which means that the items are already fixed. So we assume the user have added 2 items in the order list. So the first item is I2001, which is the Aglio Olio. So the image will be displayed first, and then it will display the name, the price, then the quantity is already fixed. So we just assume the user only going to order 1. Then since there are 2 choices, so we apply the second choice first. Then the customization only have 1, so we just assume the user that tick the checkbox for the customization. Then next is the second item. The second item, the same with the first item. The difference is only here, which is the user might only want to choose the first choice, but no customization. So both choices are different. So one is fish, one is chicken. Then now we talk about the CSS part. The CSS part, basically, there are only a few important CSS element that I want to talk about, which is the font family. Font family, we can choose the font type lah. And then background color, we can choose the color. Margin is the gap. Then margin bottom is the gap at the bottom of this class. Then font size, font weight is whether bold or not bold, or any other thing. And then color is the font color. Okay, so the display flex will make the items to be displayed in the flex box, which means that the item is displayed in one box. So later we will see. Then item margin, I think almost the same thing here, only a very basic CSS. Then now we proceed with the web page here. So in this web page, we can see that okay, all menus are displayed normally here, and then the user can choose whether they want to have mushroom sauce or black pepper. Okay, either one. Then they can also choose whether they want to have extra sauce or not. Then the static order list is here. Okay, so the user can see, okay, item image, item name, item price, quantity. Fish is their choice, and then whether they want to have extra topping for this. Okay, so the total price here is taken from two value, which is the 10 here from Aglio Olio and 11 here from Carbonara. So after totaling up, we get the output is 21. So the user can directly place the order. So all of these value here, even they are statically, but they're still, but the item information is still retrieved from the XML using XSL. Okay, so now we proceed with the Java code. Okay, so Java code here. Okay, so first we create a document builder factory, new instance for it, and then we create a document builder in the document builder factory. Here we create a new document here. So the root element, we create a root element for the document. So document create element, food ordering. So food ordering is our root element for our XML. After that, we create the root element, then we create the head element, which is the menu here. Okay. Then after we create the menu, we create category, which is the child element of the menu. Okay. So we append the child category 1. So which means that the category. So this category is a child of menu. Okay. So in category we have an attribute called cat ID, category ID. So set the value for the category attribute 1, and then we set the attribute node cat attribute 1 to category 1. After that we set a name for the category as an element. So just now we talked about ID. ID is in attribute. So this is in an element. So we create text node, append child for category 1 as the cat name. So we also include the cat image, but it is an empty element here. So we didn't append any text. We didn't create any text node for this. Then the next one is item. So okay, so the item, it contains 2 attributes. So the first attribute is the item ID. So item ID, we set the value for item ID I1001 for the first item, and then we set attribute node for item 1, which is this attribute item 1 attribute 1 for the item 1, and then the item 1 attribute 2, we also set a value called C01, which is the ID reference for the category. So we set attribute node here. So next we create a child element for the item, which is called item name, which is called name. Okay, so the name of the item that we create text node is chicken chop. Then we append child for item 1 with item name 1. Then for the image, item image, it also doesn't contain any text node, but it contains attribute for the image file name. So the image file name is chicken chop. and then we set the attribute to item image 1, which is this image element. For the price, we also create text node for it, 12.00, and then the element name is price. So we append a child for item 1 with item price 1. So for the choices, there are two child elements in choices, which is the choice. So item 1, there are two choices in item 1, and then we create two child elements here. The first child element text node is mushroom, and the second one is pepper. So we append a child for item choices. So with item choice 1 and item 1 choice 2. And then we also allow the user to have customization here. So we create an element called customization. Okay, here. Then the text node is extra source. So after that, we append a child for item 1 with item 1 custom 1, which is this one. So the rest from item 2 until the last item are almost the same thing. So I just skip it. So we proceed with the content of XML, how we transform the content to XML. So we are using the transformer here, transformer factory. We create a new instance for factory, and then we create a new instance for the transformer. So we are using the transformer to set the output, to create output for XML file. So here, we create a DOM source. The source is which is the dot is this one, where we created earlier in this Java file. Here, document builder, document. Okay. So we are using this document, which already is already filled with the items, the XML elements, attributes. So source is already created. So the result will be created also with a name called record.xml. So we transform this into with the source and the result. So the source is this one, the document, the result is record.xml. So besides that, we also need to output the XML to the console, which is the CMD. So we need to stream the result with in console. Then we create a new stream result, and then we transform it from source, which is this one, to console result. So now let's run the code. Okay. So we compile first. As we can see here, the Java class does not exist here. So we compile it, ordering.java, and then we run it. Okay, as we can see here, the record.xml is generated, and then the output here is displayed normally, which is I think is error-free here. Then let's take a look at the XML that generated just now. So the output, okay, so you can see the output are displayed normally. Okay, so thank you very much for watching this video, and goodbye.
Good day, sir and madam. My name is Shabesan, student ID 120120530. In this video presentation, I will show you about the Part B question 1. In this question 1, it requires us to create a GNI programs to calculate the house loan. The first native method is to calculate the monthly payment, while the second native method is used to display the amortization table. So first of all, to answer the question 1, I have created a Java main program called houseloancalculator.java. In this houseloancalculator.java, I've declared 3 native methods, including a money calculation, amortization display, and the third extra features, which is to calculate the difference monthly payment. So in the Java programs, first we have to take the user inputs, including a loan amount, interest rate, total payments per year, and the number of fields. And we pass it to the first native method when we're calling it. So in this first money calculation native method, we calculate the money rate payment with the formula given, and we return it to the Java main program. So it will showing that the calculated money payment is the money payment in table format. So that we call the second native method for displaying the amortization table. In the amortization display native methods, basically we use it to showing a table of money payment, interest, principal, and balance. So first, calculate the interest, principal, and outstanding, so that we print the table in the native method. Thirdly is extra features. These extra features have demonstrated the usage of GNI array, and these features basically is used to calculate the monthly payment to be paid with the same rate but the different loan amount. So we get the loan amount from the user, and we store it in an array, and we pass it to the third native method called difference money calculation. These features refers in the native method. We obtain the length of array and a copy of array. And after that, after we get a copy of array and we calculate the monthly payment, and we create a new GW array to return the result. So then we set the element of a result with array with calculated money payments, then we can return the result to the Java main programs. So in these Java main programs, it will print the updated money payment to be paid for loans. And so that's all for the programs. So that's all how we write the Java program and Java native methods. So now I will be showing the output of the program. For checking the output, we first enter Java custom calculator, and we key in the loan amount, interest rate, total of payments per year is 12, and the number of years is 1. So after that, it will calculate the money payment derived from the first native method, and this amortization tables is from the second native method. So we get the user input to do you want to calculate the different amount in the same rate, and press yes. And this is a third extra features. So how many numbers of different loan amount you want to calculate? So we press 3. Then he asks to enter the loan amount for loans number 1. So first enter first loan amount that we have, get an answer to validate this function works. Then the second loan amount, we put 25,000 and 30,000. So we will calculate the money payment to be paid from the native method and the first native method, showing the same exact result as the first native method, and the second native method from the loan amount, and the third as well. So that's all for my presentation. Thank you.
Good afternoon, sir. I'm Raymond, and my task for the project is to complete the part B for the question 2. It's a cassette cipher technique, and user need to input random text in the system, and after that the system will generate the encrypted message with the cassette cipher, and after that will show on the command prompt, and later on I will show the Java code and the C++ code. And this is the source code for the Java part, and the public native way is to create a GNI export at the C++ language there, and to load the C++ language with the system load library, and the C++ call C cassette cipher, and after that cassette cipher CS equal new cassette cipher is means that cassette cipher need to create a new parameters called CS, and after that scanner input is to take the input from the user and store into the input. And after that system.out.println is to let the user enter any text, and after that the text will save into the original parameters and send to the serial bus. And the encryption key value is to let the user choose how many keys that the user want to encrypt. Something like the text is ABC,
what if the user type the one encryption key value, and the encryption key will become the BCD, something like that. And the below part is to show the original text and the encryption text, and after is the decryption text. And right now is a C++, but the Jena export, the first there are three Jena export at here, same as the Java source code. There got three public void native, and the first one Jena export is to get the input from the user and transfer into the C++, and after that all the text will change to the character array. And the second Jena export is to encrypt the text from the user. The text will change to character so that each of the character will encrypt through the cassette cipher encryption, and the encryption text will transmit to the third Jena export. The third Jena export is to decrypt the encrypted message with the cassette cipher. And this is the algorithm for the cassette cipher. This is a decrypt for the cassette cipher, and this is the encrypt. And that's all for my part. Thank you, sir.